Hello, today we are working on lesson 5.2. We're continuing with solving systems of equations. Our last lesson dealt with graphing systems of equations, but today we're going to solve them using a method called substitution. So when I talk about substitution and we're trying to find that solution, an ordered pair, then we look at the equation, and if we can easily solve one of the equations for a variable, we will use this method of substitution. And what I mean by that is if you look at equation number 1 right here in our first example, this y is isolated. It has no coefficient in front of it, and we can easily manipulate this equation into slope-intercept form so that we can use this method of substitution. So we have 3 methods. We have graphing, substitution, and elimination. I'll be teaching elimination next. But when you're trying to figure out which method to use, this is one of the ways you could tell if substitution is going to be a good method, is that if one of the variables is already isolated, or not isolated, but if it doesn't have a coefficient in front of it. So this very first page is going to walk you through step by step how to do one problem. So we are going to start with this very first step. And this step tells us that we're going to rearrange one of the equations so that it's set equal to either the x or the y variable. For this example, I will take the equation 1 and set it equal to y. And again, I'm doing this because this variable does not have a coefficient in front of it. So it's going to make it pretty easy. All right. So the way that I do this is I write out my equation, 2x plus y equals -4. And I'm just going to rearrange it so that y is isolated. And in this case, it's going to be in slope-intercept form, but that won't always be the case. So I'm going to subtract 2x from both sides. And I end up with y equals -2x minus 4. So that was step 1. All right. Now step 2. Substitute the equation you solved for in step 1, which is this one right here, into the other equation, which is going to be this one right here. So we took this and we converted it into this, and now we're going to substitute this into this equation. And it is a little confusing at first, but as I go through, I'll explain a little bit more. In this example, I will substitute -2x minus 4 into the second equation, equation number 2 up here, for y. All right, let me explain this. When I rearrange the equation and I set it equal to y right here, you can look at this equation and you can say, okay, well, y is -2x minus 4. Well, if that is what y is already, okay, I can take this right here and I'm just going to put a little parenthesis around it. I'm going to take what y is and I'm going to plug that into the y into equation number 2 because y is -2x minus 4. It would be like saying, okay, when I solve for x in equation and I get x equals 5. Well, that's what x is. X has a value of 5. Well, in this case, y has a value of -2x minus 4. We just haven't seen it like that before. Okay, so let me go over step 2 again. We're going to substitute the equation you solved for in step 1 into the other equation. In this example, I'm going to take what y is, it's -2x minus 4, and I'm going to put it into the second equation for y. I'm basically replacing what's in parentheses here where the y is. Okay. So let's go ahead and do that here. So I'm going to write out my whole second equation, 5x minus 2y equals -1. And then I'm going to take this right here and I'm going to plug it into the y. And what that looks like is 5x minus 2, stop because I'm replacing the y. And I put parentheses in front of it. -2x minus 4, and then I finish writing out my equation equals -1. That was step 2. All I did was I substituted what y is into the other equation. the second equation. Okay. All right, we're going to go down to step 3. Now solve the equation you generated in step 2. That's this equation right here. And we're going to do right here, just so you know, for the given variable. Now, what that means is for the given variable is sometimes it'll be y, sometimes it'll be x. But in this case, notice the only variable we have in here is x because we got rid of the y. Now, since we got rid of the y, we could solve for x. Okay. And so in this case, I will simplify the equation to determine the value of y. Oh, this should say x, sorry. Change this right here to an x. Okay. I need to find the value of x. All right, so I'm going to rewrite this equation down here and I'm going to solve. All right, so the first thing that you need to do is you need to use substitution. So I'm sorry, not substitution, getting all my vocab mixed up. You need to use the distributive property. So we're going to distribute the -2 to both terms inside the parentheses and just bring down this 5x. -2 times -2x is positive 4x. -2 times -4 is positive 8. And that equals -1. Now what we're going to do is we're going to combine like terms on the left side. We have 5x plus 4x is 9x. And then we're going to subtract 8 from both sides. 9x equals -9. And then you divide both sides by 9. And we get x equals -1. All right, so we found our x. We found half of our ordered pair. We found half of the solution to the system of equations. Okay, so let's look at our last step here. Take the value of the variable you solved in step 3. This is the value we got, and plug it into one of the equations you started with at the top. So we're going to take this x equals -1, and we're going to choose either one of these equations. I always choose whichever one looks better to me. There's no rhyme or reason. Okay, you just pick which one you like. I personally like equation number 1, so that's the one I'm going to choose. And then once you plug that in, you will solve for the other variable. In this case, because we've already solved for x and we're going to plug that into the equation, we'll need to solve for y. So in this case, we will take x equals -1 and plug it into the first equation for x to determine the value of y. All right, so we're going to take -1 and we're going to plug it into the first equation for x. So here's our first equation, 2x plus y equals -4. We are going to plug the -1 into where the x is. And now all we have is the variable y. Okay, hold on just a second. My screen stopped moving. Okay. Okay, so now we're going to solve for this y. So we have -2 plus y equals -4. And then we add 2 to both sides to figure out what that y is. Y equals -2. So we have our x as -1 and our y as -2. Okay. Now, with graphing, you don't check as much as you do with something like substitution. So what I'm going to do is I'm going to show you how to go back and check to make sure that your solution is correct. Okay, so I'm going to take -1, -2, and I'm going to plug it into both of these equations, and I'm going to check my solution. So here's my check. Okay. So my solution down at the bottom was -1, -2. So I'm going to take my first equation and I'm going to plug, see if it's true. Okay. So we have 2 times -1 minus 2 equals -4. So we have -2 minus 2 equals -4. -4 equals -4. So that checks out. Now I'm going to do it for the other equation because it has to be true for both equations, not just one. And just because it's true for this equation doesn't necessarily mean it's going to be true for the other. We need to check both. So I have 5x minus 2y equals -1. That's my second equation, and I'm going to plug these in. So 5 times -1 minus 2 times -2, and we're going to see that equals -1. And look at that. They both check out. So this is a solution. Okay, now I know, especially the first time you're introduced to this method, it can be a little bit tricky. And the key is to go back through and make sure that you understand the steps, understand what we did. And then as you go through and you do the first few problems, you're following those steps one by one. And then the more that you practice this, the more you, the steps just become natural. You'll remember how to do them. Okay, so I'm going to go back and forth for the first two problems just to refresh our memory of what the steps are, and then I'll go a little bit quicker after that. Okay, so let's go to the back. There are a lot of practice problems on here, but I want to make sure you understand. So example 2, we have two equations, and I actually put the instructions up here, so we'll just refer to those. And so let's look at step 1. It says solve one of the equations for x or y. This means you need to rearrange one of the equations to be set to x or y. Well, if you look at both of these equations, they're both set equal to y. So we can skip that step. Okay. Step 2, if you set the equation equal to y, then plug the expression into the second equation and solve for x. If you set the equation equal to x, then plug the expression into the second equation and solve for y. All right, so since these equations are both set equal to y, what I'm going to do is I'm going to take this first equation where it says that y is 2x minus 5, and I'm going to plug it into the y, into that equation. Just substitute it, okay? That's where we get the name for the method. I'm going to substitute this y with 2x minus 5. So it's going to look like this. 2x minus 5, because I put it right here, is going to equal 5x plus 7. And now we've eliminated that y by substituting, and we're just left with x. So we're going to figure out what x is, and then we'll follow the next step. Okay, so this is just solving a multi-step equation. Subtract 2x. Okay, you should have gotten that x is -4. So once we've done step 2 here, step 3 says plug in the answer you got from step 2 into the first equation and solve for the other variable. This says the first equation. It actually doesn't matter. You can use whichever equation that you want. I like the first equation. It looks a little easier, smaller numbers, I guess. But honestly, it doesn't matter. Either one you put it into, you'll get the same value for y. So I'm going to take this first equation, y equals 2x minus 5, and I'm going to substitute the -4 into where the x is right here. Okay, I just plugged it in there. So we have y equals -8 minus 5, y equals -13. Okay, so our solution for this problem is -4, -13. Okay. Okay, so we're going to move on to example 3. Okay. So going back up to our steps, it says solve one of the equations for X or Y. And this means we need to rearrange it so either X or Y are isolated. Well, in this case, they've already isolated the X for us. So that's what we're going to do. We are going to take what X is negative 2Y plus 11, and we're going to plug it into the equation. We're going to plug it into the equation over here for X. Okay. So what that looks like is we're going to take 12 and we're going to multiply it by negative 2Y plus 11 because we're substituting this X with negative 2Y plus 11. Okay. And then we just finish writing out the rest of the equation. Minus 6Y equals 12. And again, you're going to notice that in this case, we got rid of the X's and now we're just left with Y's. So we're going to figure out what our Y is before we figure out what our X is. And that's okay. You'll find that you'll do it different ways all the time. Okay, so let's go ahead and distribute this 12. We get negative 12Y plus 132 minus 6Y equals 12. Right? Now we combine like terms. So negative 12Y right here and negative 6Y give us a negative 18Y plus 132 equals 12. Now we subtract 132 from both sides. And we're left with negative 18Y equals negative 120. Oh, you know what? I'm sorry. I messed up right here. This should be a negative 24. Fix that. This should be a negative 24, meaning that, so then negative 24Y minus 6Y is a negative 30Y. Sorry about that. And then we divide everything by negative 30. And Y equals 4. Okay. So now we're going to plug in what Y is into one of these equations. And this equation looks a little bit easier to me. So I'm going to use this one. X equals negative 2Y plus 11. So I'm going to plug Y equals 4. So since Y is 4, I'm going to plug it in where the Y is. So negative 2 times 4 plus 11. X equals negative 8 plus 11. X equals 3. So our solution to this system is 3, 4. Okay, let's go ahead and move on to example 4. So in this case, again, we have a variable isolated, negative 3x plus 1. That's what Y equals. So I will plug this into the Y over here. Now, one thing that I want you to know is that when Y is by itself over here, remember there's a 1 in front of it. So we're going to multiply that whole thing by a 1. And that might seem like you really don't need to do that. But I want you to get in the habit of doing that, because if this were a negative Y, you'd have to multiply everything by negative 1, and that changes up your equation. So we have negative 5x plus 1 times negative 3x plus 1 equals negative 7. And now I'm going to solve this for x. Okay, so you should have gotten x equals 1. Now I'm going to plug this into the second equation here. and y equals -2. So our solution to this system is 1, -2. All right, let's move down to example 5. Now what you're doing is you're kind of practicing the processes. I would probably pause the videos, try them on your own, and then as you need to check each step, unpause them and watch. Okay. Okay, now in this problem, I don't have a variable isolated. So I'm going to have to isolate one. And so now this is where you need to look. You need to see, okay, are there any variables that don't have a coefficient? That's where you want to go first. Well, this one right here doesn't have a coefficient. So that's the one that I'm going to solve for. I'm going to solve for that y. So I'm just going to subtract 5x on both sides, and I end up with y equals -5x plus 13. So now what I'm going to do is, since y is this, I'm going to plug this into the second equation where the y is. I'm going to substitute it in there. So 2x minus 3 times -5x plus 13 equals 12. And don't forget, you're distributing by a -3. So you want to make sure you do that. So you have 2x plus 15x minus 39 equals 12. This is a tricky one because a lot of people think that 51 is a prime number, and it's not. 51 is divisible by 17 3 times. Okay, so x equals 3. So now what I'm going to do is I'm going to plug that x equals 3 into one of these equations. I'm just going to do that second one, 2x minus 3y equals 12. So 2. The other one would have actually been a little bit easier, but that's okay. All right, so our solution is 3, -2. All right, let's go to the last page. A couple of these are going to be different. Well, they're all a little bit different. Number 6, you're going to deal with fractions. That's just something we have to do. So I put one in our notes. And then 7 and 8 are we don't find a solution exactly how we have on the previous ones. So as we go through those, I'll show you how to look for those types of problems. Okay, so example 6. I need to isolate a variable, and I think what I'm going to do is I'm going to isolate the y in this one. Let's isolate the x. I think the x might be a little bit easier. All right, so, and the reason I'm doing that is because when I move my 5y over, it is going to be divisible by, it's going to be divisible by 5. Let's see how this works. Okay, so we're going to add 5y, add 5y. Okay, so I've isolated my x and we're dealing with that fraction. So what we'll do is we'll take this and we'll substitute it over here where the x is, okay? So let's see what that's gonna look like. We're gonna take 3 times y plus 4/5 minus 2y equals 1. Now let's distribute that 3. We have 3y plus 12/5 minus 2y equals 1. I'm going to combine like terms. 3y minus 2y is y. Okay, now I'm going to subtract 12/5 from both sides. And I have y equals. Now, one thing that I hope that everybody understands by this point, we need to find common denominators. Well, another way to write 1 with the same denominator as this is 5/5. So 1 as a fraction can be 5/5 minus 12/5. And now it's easy to solve here. So y is going to equal -7/5. Okay. Now I'm going to take this and I'm going to plug it into this equation right here. I'm going to do that because I'm thinking maybe my 5s will cancel out, but let's see what happens. So we're going to take 5x minus 5y equals 4, and we're going to replace or substitute the -7/5 in where this y is. So. Okay, so here I can cancel out my 5s, those become 1. And I have -1 times -7, which is a +7. Subtract 7 on both sides. And x is -3/5. So we have -3/5 and -7/5 as our answer. And yes, you will come along some not so pretty answers. Okay, let's move on to example 7. Okay, I need to set one of these equal to a variable. So let's look at this. I think I'm going to do this one. And I think I'm going to go ahead and isolate the y because I know that 4 is divisible by -2. I could do this one too, but I'm going to do it with the smaller numbers. So I'm going to subtract 4x on both sides. And I get -2y equals -4x plus 5. And then divide by my -2. So I end up with y equals 2x minus 5/2. Ugh, another fraction. That's okay. I'm now going to take this and I'm going to plug it into the y right there. Okay. So we have 8x minus 8x, and then plus 20/2, which is 10, equals 10. All right. So remember, this is going to be a little bit different. So I'm going to combine my like terms. 8x minus 8x is 0x. And a lot of students will want to stop here and say, oh, there's not going to be any solution. Well, keep going. Make sure there's not going to be a solution. So now I'm going to subtract 10 from both sides, and we have 0x equals 0. Now, once you get to this point, 0 times any number is 0. 0 times whatever x value we put in here is 0. So any number that we plug in here is going to be 0. That means that the solution is infinite number of solutions. Okay. We could stop there and we know that's what it's going to be. So there are a couple ways to write this. We can say infinite solutions. We could say all real numbers. We're getting to the point where we need to say all real numbers, but I'll put both here. Infinite solutions or all real numbers. Okay, that's what the answer is. Okay, now when it's not infinite number of solutions, you would have some number over here, like 0x equals 5, because then you are expected to divide by 0. Remember, you can't divide by 0, so then that would be no solution. Okay, So this is no solution. This is infinite solutions. Okay, you might want to write that down as a little note so that you don't forget that. Okay, all right, let's go ahead and come over here. Okay, so I'm going to manipulate this one and isolate my y right here because it does not have a coefficient. So I'm just going to move 3/2 x over here. Y equals -3/2 x plus 2. And when I do that, I'm going to substitute this into the y. So I have 3x plus 2 times -3/2 x plus 2 equals -3. So let's go ahead and solve and distribute that 2. So this is going to end up being 1. So it's going to be -3x plus 4. Okay. 3x minus 3x is 0x. It's looking like it did up there, but remember, keep solving. Uh-oh. Okay, you can't divide by 0 here. So the answer here is going to be no solution. Okay. All right, and that concludes lesson 5.2.